So A is A11. A, oh, that's not A. Okay, A11. A12, 0, A22. That's A. The candidate for that invertible matrix is given there on page 122 as A11 inverse minus A11 inverse A12 inverse 0 and A22 inverse. That's what they got when they showed that A had an inverse. They showed that, so that's a candidate for the inverse of that. So then if we multiply that out, and it's first row of A times the first column of A inverse, so that's going to be A11 A11 inverse plus A12 times 0. And the second one is A11 times negative plus this is 0 times A11 inverse, and then plus 2, 0, and it's 0 times okay, then say it again. What? Okay, but when I'm doing this, when I'm doing this one, I'm multiplying this thing times that thing. Okay, I don't want to get rid of those because it'll be too cluttered. Now when I'm doing this one right here, and I'm multiplying this times this. It's the row times the column gives you the row column for that. So then when you're doing this one, you're taking this one times that one. So, do you want me to circle the last one?
No.
Okay. Okay. Now, we're going to evaluate the upper left-hand matrix. That's this one right here. And if you take A11 times A11 inverse, that's I. And then A22 times 0 is 0. Now, when I do this one, I can bring that minus sign out in front. And I got A11, A11 inverse. And then this is stick there. And then this is I. A22 times A22 inverse. Then down here it's 0. And then this is 0 plus I. Now, so I think that this is, oh yeah, okay, I made a mistake right here. This right here is a 1, 2. So this is incorrect. This is an A 1, 2 times A 2, 2 inverse. So this is I, and this is a negative I times A1, 2, A2, 2 inverse plus A1, 2, A2, 2 inverse. Then it's I down here. So what I have is an I in 0, 1 I, 0, this one. And that is showing that that if A11, it's proven this particular thing, if A11 and A22 are invertible, and I use that fact to be able to get this I right here, because A11 is invertible, to get this thing, and to get this one down here at the bottom, to get this. And you can say, therefore, theorem 8K is met. There's an 8K says that there is a matrix I actually used that 8K. That says that there is an A times D such that it equals I. And if that is true, then I could conclude that A is invertible by theorem 8A. Okay. I had to be able to use this matrix right here as a candidate for my invertible matrix of A, which was given to me in example 5. And once I put that in, then I could use the fact that 1,1 was invertible, that 2,2 was invertible to get that, and that 1,1 is invertible there, and then I reduced this whole thing to the identity. And I've shown that A is invertible if A11 and A2 are invertible. Okay, any questions on that? Okay. Okay, 16 says, suppose the block matrix A on the left side of 7, so that's up there in 15, is invertible. And A11 is invertible. So we're given those three things. The block matrix A is invertible, A11 is invertible. Show that the shear complement S of A11 is invertible. And it says, a hint, it says the outside factors on the right side of 7 are always invertible, and verify that. When A and A11 are both invertible, 7 leads to a formula A inverse using S inverse and A11 inverse on the other matrices in A. So it says A is a block matrix. This is given. And A11 is I think they're both invertible. Is invertible. And A11. Okay, then on the right side of the equation, the hint is that right side of that equation which is I 0 x I and there's this equation matrix. Matrix is I 0 minus x I such that okay, how do I undo that? Click that. If I take this particular value right here, and I take this one, then I can show that I changing the order of the multiplication. No matter which way I multiply it, that inverse is an inverse for this particular matrix right here. And then you can, likewise, you can say there's a I minus y 0 I, and I'm not going to show either way, but it's when you do I y 0 I times I minus y. So this one's the invert of this one. this thing is the invert of this one. I wanted just to show that. And both of those matrices are square, and therefore I0 xi and IY 0I are both invertible. So then if we take our matrix, if we take this matrix, call it A11, A12, A21, A22, and we multiply it by I0 xi inverse, and that exists. We just show that that exists. And then we multiply it on this side by IY 0I, its inverse, and we've shown that that exists. And then you take the right-hand side of the equation and you multiply I0 xi inverse. And the right-hand side of that equation is that.